Hi, welcome to Neural Craft. Today we are going to have a hands-on session on machine learning. This lesson is only intended for students who have already studied machine learning theoretically and now they are going to implement using Python. So, first thing in machine learning is the most important thing that is required in machine learning is handling your data because the garbage comes in, then garbage goes out. It is the principle that is followed in classical machine learning. How good your data is going to determine how good your output model is. So, in this tutorial, we will be learning how to load the data set and we will also do the descriptive analysis and the statistical analysis of data. So first thing is we are going to do data understanding that includes loading data set and then exploring the data sets. So let's move into our Python notebook. So this is my VS Code and now here I am going to initialize my virtual environment with the help of UV package manager. UV init is the command and now I have initialized. Now I am going to create a virtual environment with the help of UV For initializing this environment, we will use this command source venv slash bin slash activate. I have successfully initialized my environment and now we will create one requirement.txt file where we are going to uh, place all the dependencies which we want to download. So in this way I have created one. You can see in the left window that I have here. I am going to just put two main libraries which are used in classical machine learning. These are for data pre-processing only and some mathematical tasks that need to be done. So pandas is for the loading and working on Excel sheets and CSV data. NumPy is for performing the mathematical operations. Some functions inside pandas also use NumPy and the backend. So we will look at them when we go further in this playlist. So now I am going to install these dependencies with the help of this command requirements. uv add minus r requirements.txt is the command which is going to install all the dependencies inside this text file. Uh, so as you can see, if I look at my pyproject.toml file, I have two dependencies installed here perfectly with their version specified also, and Python version also is mentioned here. So this version is for our like this project, which is version is this 0.1.0, but the Python version is mentioned here only. So every time, since I'm using Python 3.10, so if you want to run this file by downloading it from GitHub, then you must have at least 3.10 as your Python version. Now we are going to create data processing.ipynb Jupyter notebook. Now here we have to select the kernel which we are going to use. I am going to use this virtual environment kernel only. Now if I have to just import pandas and numpy as np import pandas as pd. These you always have to use these two libraries mostly for the data preprocessing tasks. Maybe you will be prompted to install the ipy kernel. Please do this and then you will be able to import them. Now we will move ahead to the downloading the data set. So let's call a variable named data which is going to use pandas dot read csv function, and we are going to just select this file, copy the relative path and put it here. In this way we have to put quotes on both sides and make it inside this function code only. Now we have got the data. Now we have to look what is inside this variable data. So data dot head, this is the command which is going to display the first 5 rows. Just have a look at it. press shift enter, we have got this table which contains columns like pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, pedigree function, age, and the outcome. So out of these columns, the first to the last second, before the last column, all these contain numerical values. But as you can see, the last column contains only 0 and 1s. So uh, this suggests that this data set is a classification data set. So uh, we can also like check the shape and everything for this data. We just have to use this function data dot shape. Shape object is not callable, so you can see there are 768 rows and 9 columns in this data. This is the whole content of this data set. Now uh, now we are going to check what is the data type for each of the each of the attribute basically. So we are going to say print data dot d types. So you can see pregnancies to insulin, these are its 64 integer variables, and BMI to outcome, all these BMI and age, BMI and diabetes pedigree function is a float, basically a decimal, and age and outcome are integer values. So in this way we can check like how are what are the different types of our data, and also we can like check more than 5 rows. We can put any number here, like if I put 200, then it is going to show me 200 rows. And if I just put here print command, it is not showing here because the terminal is not that big here, but this function, this method can be used to fetch 200 based upon how many rows you have in your table. So head function can be used. By default it will only print 5. So this is related to data visualization, and now we are moving forward to the descriptive statistics functions like count, mean, standard deviation, minimum value, and the percentiles like 25th, 50th percentile, 75th percentile, maximum value. We can get these values from the data for each and every column, right? So what we are going to do is I'm going to first tell you a very simple function, data dot describe. Here you can see you have got all the result, count, glucose, count for glucose means how many rows are there, for pregnancy, for glucose attribute, for blood pressure. What was the mean value? Mean pregnancy value was 3.84, blood pressure was 69, skin thickness was 20.5. You can see it is shown here. You can also check the maximum value was 17 for pregnancies. For blood pressure it was 122, and you can see for insulin it is 846 for the entire data set. And the outcome values, for the outcome values, as you can see, maximum value is 1 obviously, and the minimum value is 0 because there are only 2 values. So for outcome we can ignore this minimum and maximum value, but we can check this 75th and 25th percentile. This gives us a peek at the data that how many numbers have 1 and 0. Also mean and standard deviation. Mean value is not a good measure for this outcome because it's a classification problem, and it is only a it's not a numerical value, it's just a classical classic classification variable only. Now now what we are going to see, we are going to see the class distribution. In class distribution, what we are going to do, we are going to use the group by function. So if we type here like this class counts, then we can get something like this. It's like data dot group by outcome. and here we are going to just write size and print the class nodes. So for 0 we have 500 rows, and for 1 we have 268 rows. So uh, this tells us that this data is imbalanced, class imbalanced. So because there are more number of points for 0, and one 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 class has only 268 variables. So if we ever try to build a simple classifier on this, we are surely going to have it overfit model. So we might have to use some other matrices like confusion matrix, F1 score, and all. We will discuss about this later. Now we are going to see another important attribute, that is correlation. So correlation is going to be, we can use it directly from pandas only. So correlation is going to be data dot core. So we have to provide it the names, and we have to provide it the names of the columns within which we are finding the correlation. So we can use like this data of, we are going to use glucose, let's say glucose, and we are going to find this its relation with data of insulin. Let's see what we are going to get printed. Wait a minute. Yeah, it's showing 0.33 correlation. So it's not showing that much correlation. We can check it with another variable, like we can say diabetes pedigree function. So I'm just going to copy this, and if I just place it here, we got a very less correlation here also. uh, Maybe we can check any another variable, maybe blood pressure. I'm just looking for anything like beat correlation and everything. Here we got 0.15. So let's do one thing. Instead of finding correlation for each and every one or individual, we can find the correlation for all. So for correlation matrix, data dot core matrix. If we do this, you can see here we have got a matrix which contains columns on both rows and columns have these attribute values, and then we have these numbers. So here you can see the outcome has high correlation with glucose. I mean, in this data we have only 0.46 as the high correlation value, and you can see here age and pregnancies have a half correlation, which is also a good correlation. I mean, by good means high correlation with respect to this data. If you use any another data set, maybe there will be more dependable variables, and maybe then in that case in which the two attributes or two columns have more correlation, in that case they might lead to overfitting and of the data of the model, because both the attributes are going to present the same condition and lead to redundancy. In that case, we have to remove any one of the columns, which is also a very good data pruning technique, which we will discuss later. So, as of now, we have done most of the things. So as of now, what we have done is we have loaded the data set, then we have find its shape, then we can also check which data types are there, and we can have a peek at the data from starting or from the end, or any number of values by putting a number here. Also, we can get the complete statistical distribution of the statistical description of the data using data.describe. We have also find out the class distribution using group by function only. We can find the correlation between any two columns, or we can also print a correlation matrix. And then as of now, the basic things that we need to put on a data containing numerical variables or classical variables. In this, categorical variables, by the way, it's not classical. Classification is a task which requires some categorical variables. So as of now, I think this is enough for this video. We'll meet again with the next tutorial. Thank you.